Newton's second law states that the acceleration of an object is proportional to the force acting on it and inversely proportional to its mass. Newton's third law states that for every action there is an equal and opposite reaction called action and reaction forces. The direction of the force of the first object is opposite to the direction of the force on the second object. According to Newton's second and third law, when a system accelerates mass in a direction, it will cause a force of equal magnitude in the opposite direction. In this experiment, these laws will be observed using the balloon rocket. When a blown balloon is released, the air comes out with the force from the balloon's mouth to the outside air, equal in magnitude but opposite in direction. The force propelled the balloon up.
After conducting 3 trials with the small, medium, and large balloon rockets, we were able to calculate the force of thrust that acted on the balloons. The main components that deal with calculating thrust are the weight and acceleration. The balloon had a mass of 3 grams or 0.003 kilograms, which stayed constant in all of the calculations since we used the same balloon in each trial. The acceleration was then determined by taking a look at the slope of each velocity graph. For each trial, we have highlighted the acceleration points in blue, and the rest of the points are highlighted in yellow, which show the constant velocity that was maintained after the initial period of acceleration was finished. First, we can take a look at the small balloon's velocity graph. We found the acceleration to be 41.05 meters per second squared. Then the slope that we found for the medium balloon was an acceleration of 12.68 meters per second squared. Then lastly, the large balloon had an acceleration of 59.66 meters per second squared. So then the overall equation that we used was thrust minus weight equals mass times acceleration. The final results showed that the small balloon had a thrust of 0.153 newtons, the medium balloon had a thrust of 0.067 newtons, and the large balloon had a thrust of 0.208 newtons. It may seem odd that the smallest balloon had a slightly larger thrust than the medium balloon, but it makes sense because the smaller balloon is thinner, so it has better aerodynamics, which causes it to travel faster during the acceleration period, but at a shorter distance overall, while the medium balloon accelerated slower but traveled a farther distance overall because it had more air to keep it going. We also calculated the constant velocity, which stayed the same for each trial because the same mass was used for the balloon the whole time, and this resulted in a common constant velocity of 0.0294 newtons for all 3 balloons.